we decided there were actually 24 in the range. And we had a quick discussion about how it's not that big of a deal. Honestly, we're going to let technology usually count this stuff for us. It wouldn't even be an issue. Hence, that was that second quiz problem where I had you use Excel to... Did anybody try that? To do the use Excel to drop the data in and work for you? Okay, yeah, it's a nice feature. So there's one standard deviation. 2 and 3 are very, very similar. Two of them looks exactly the same, except as JC said, instead of just going out one S, you're going to go out 2 S's on each side. And this is where your weighted average is starting to show up as far as a weighted average from mean on average distance. I said the right words in that statement in the wrong order. On average, it's the distance that the data points are from average. And you have to wait. So certain ones are only out this far, as Hattie said, most of them. Certain ones are out this far, certain ones are out this far, some are out even further. Some are out even further. So for this data set, x bar and plus or minus 2s is negative 15 plus or minus 32 pounds. And then all we got to do is add and subtract that from the 15. So it looks like we go down 47.
47 and 17.
Thank you. 47 pounds up to 17 pounds. Let's re-ask Hattie's question. Or re-paraphrase Hattie's question. How many data points are in that range? Unfortunately, all that awful counting I just did, I can use that to my advantage, because all the ones we just counted at 1 standard deviation are still in 2. All we gotta do is pick up the ones that weren't in the 1. Let's see. 47 to 17. Did I steal somebody's pencil? I did. This is Andrew's pencil. There you go, sir. 16? Looks like 16 is. Okay, negative 58's not.
And 21?
And 21? I concur. But the rest of them are? That was a pretty slick way of doing it. Finding the ones that aren't. And then whatever else is left has to be. That's good. That's good. I like that. So it looks like in this data range, we got 33 in the weight loss data. Honestly, that number of standard deviations is the most important one to remember. If you remember almost nothing else from 243 and you walk into the world, if you can remember that, and we'll come back to why that's so crucially important in a moment when we actually do some percentages, Hattie's percentages and also Scott's percentages again. That's the most important one for research. When you actually consume research journals, social journals, psychology journals, alternative energy journals, there's a thing called confidence that keeps popping up into journals. And confidence is usually set at 95%, and it's directly tied to that. It will come back. Please!
Are you going to do a box and whisker plot?
We will. I'd like to hold that off until we do relative position, Harrison, and the reason is it's based on quartiles, which are based on relative, not absolute position. It's one of those things where your book has everything in the very beginning, and then they say, okay, we got it now. Now remember that in 3 weeks, remember this right now. How about we just remember this now and then pick that up in 3 weeks when it's important? And that's kind of where I'm at. We're going to do them. Yes, we have to do them. They're hugely important. But they get confused at this point because they say 2 seemingly different things.
Okay.
Is that fair?
Yep.
Good. Great question. Oh, I'm thinking Tuesday of next week we're into that.
Okay.
But this doesn't tie directly to that, which is why I like keeping them separate. At least for now. And last but not least, the one that you often hear about is 3 standard deviations. 3 standard deviations. And like I said, you can have as many standard deviations as you want. They can be fractional. You can have a half a standard deviation, 1.5 standard deviations, 0.1 standard deviation. It doesn't matter how many standard deviations you have. These are the 3 that you hear very often. Like I said, this is the most important one. But for 3, it's the same thing. You take your average and add and subtract 3 of those S's. So that's going to be negative 15 plus or minus, let's see, 3 16ths is 48, I think. If I did that right. So that's going to break down to 63 and 33. Did I do that right? Yep. So that's negative 63 pounds up to 33 pounds, and I think, if I remember the numbers, I think that picks them all up now, doesn't it?
It does.
Yeah, that gets the negative 58, it also gets a 21. So now we got them all. All in the weight loss data, all of them in the weight loss data fit within 3 standard deviations. FYI, it doesn't always work that way in data sets. Sometimes it does, sometimes it doesn't. Sometimes they're all within 2. Sometimes they're all within 2. They're very rarely all within 1. I've never seen a data set that's actually all within 1. And this goes back to what Hattie and Scott were talking about. There are predictable percentages of data that have to fall within certain numbers of standard deviations if, and here's the if, the data has to look a certain way. So here's what I want to do. We haven't looked at our data yet. Okay, we haven't looked, I haven't even stopped to ask you guys, should we even have used the average? I mean, hell, there's a negative 58 there. That seems kind of weird, doesn't it? That's like a hugely small number. Hugely small. Very small number. Maybe it's an outlier. Maybe it's pulling the data way to the left. The 21 might be overly big. Maybe it's pulling it way to the right. Maybe we shouldn't even be talking about an average. So here's what I'm going to do next. I want to look at the data. I want to take a look at this data, and I want to see its shape. Remember the discussion we had about center? If you've got bimodal data, if you have skewed data, you shouldn't use the average necessarily. Can you tell by this string of data and these statistics what the shape of the data is? It's too hard. I can't group that in my head. But the TIs allow us to not have to group in our head. What I want to learn next is how to make a histogram. Box will come next there, so I promise you. But a